with lenses, specifically converging lenses. And this is a problem in which we have two lenses, and we're told to figure out what the distance of the final image from the lens on the right is. So we know our light rays are coming from the left, just by default. And to approach this problem, two identical converging lenses separated by 16 centimeters have focal lengths of 4 centimeters. An object is placed 25 centimeters to the left of the lens. What is the distance of the final image from the lens on the right? You need to know the mirror equation or the lens equation. They're the same thing. And you need to understand the concept of one lens's image is going to be treated as the other lens's object. So just for simplicity's sake, let's write out the mirror or lens equation off to the left here. So 1 over the focal length is equal to 1 over the distance object plus 1 over the distance image. So sometimes it helps to draw out the scenario that the question is asking about. So we can draw a quick sketch. So we have one lens, we have two lenses, and I'm drawing them like ovals because they're converging. The focal length is 4. Here we have 4, 4, and they're identical. So they both have the same focal length. They're separated by 16 centimeters. And object is placed 25 centimeters to the left of the left lens. So here we have our object. Let's draw this line. And it's 25 centimeters. So it helps to define your variables or just organize all of the information that you're given from the get-go. So here we have two identical converging lenses separated by 16 centimeters, have focal lengths of 4. So we know our focal length is 4, so F equals 4. And object is placed 25 centimeters to the left of the left lens. So our object distance from the left lens is 25. So DO equals 25. And we don't have DI at the moment. So that's what we're going to solve for. Because like I said, the distance of the image of one lens is going to be the object of the other lens. So, or the object distance of the other lens. Let me rephrase that. The image distance of this first converging lens will be where the object is for the second lens. So the second lens, we're going to have to extrapolate where exactly, how far away the object is. So we're going to have to find out what the distance of the object is. So I might have misspoken earlier in saying DI of the first lens will be equal to DO of the second lens. I of the first lens will be equal to O of the second lens. So we're going to have to figure out what DI is exactly of, what DO is exactly of the second lens to find that final image. So let's start by solving for DI of this first lens. So we have 1 over f is equal to, I'm just rewriting the Lenz equation so we can look at it down here. So we have 1 over 4 is equal to 1 over 25 plus 1 over di. And we're looking for di, so let's get di on one side of the equal sign. And we do that by subtracting 1 over 25 from 1 over 4. So now we could just solve for di. And I do not have a calculator on me, so let's work it out. 1 over di is equal to, and to subtract fractions, they need to have a common denominator. And it looks like the common denominator of 25 and 4 will be 100. I don't know if that's the least common denominator, but it's a common denominator, so we'll just work with it. To get to 100 from 4, we multiply by 25. And to get from 100 from 25, we multiply by 4. It's still minus. So 1 over di is equal to 21 over 100. And I want to say that is 4 close to 5. Let's see what 21 divided by 100 is. 0.21. So 1 over di equals 0.21. And if you want to solve for di, when I said it's 4 close to 5, I was talking about 1 over 0.21. So di is equal to 1 over 0.21. So it should be around 5. Let's see what the exact number is. 1 divided by 0.21. Yeah, 4.76.